How are we doing today? We have an incredibly bizarre looking puzzle by Qodec, based on an incredibly bizarre puzzle from Jay Dyer that we did 79 years ago or something like that. But this is the most voted for puzzle. This was voted for by David, Alathana, Russ, Tallcat, and Luda. So we'll have to look at get the rules to this. So this is a house numbering puzzle, which, as I said, I think I've done exactly one of before. And so in addition to the Renbon, which if you are a regular around the channel, you will be intimately familiar with, we also have to indicate one cell in every row, column, and box. So, for example, we might indicate this cell. And if we do indicate this cell, then in every house that contains it, and house is just slang for row, column, and box, we have to start that house with its position. So, for example, this would contain a 5 because it's the 5th in the row. This would contain a 4 because it's the 4th in the column. And this would contain a 2 because it's the 2nd in its box. And so we are obligated to indicate a cell in every row, column, and box in such a fashion. The tooth, yes, the tooth is correct. I apologize if I didn't say tooth before. Let's see. Are there any easy cells that definitely can't be thingy? I don't know. Oh, I did not know that. So I am glad. I am glad you mentioned that, Tristan, because I don't think you mentioned that when you were explaining me the rules beforehand. So I guess the disjoint box index thing is follows from that rule, Selena, that I didn't mention because I didn't know it. I was trying to decide, it seems like this is the box that is the most natural to start with. So, these digits, for example, are not 5. Because there's definitely a 5 along this Renbon. Let's see. Now, it's weird how, the indicated cell, its value and the thing that points at it are different. I was trying to figure out, if I put a 1 here, then it wouldn't work or something, but I don't think. It's weird because I was trying to do something where this Renbon obviously breaks if, but the fact that indicating a cell doesn't tell me anything about its value makes that tricky. Oh yeah, that's exactly it. Yeah, those are entropic. That's right. Selena is correct. So the point is, one of these is in box 1. Box 1. One of these is pointing to something in box 7, and so it's a 1, 2, 3. One of them is pointing at something in box 5, so it's a 4, 5, 6, and one of them is pointing at something in box 9, so it's a 7, 8, 9. Not necessarily in this order, but we definitely have a 1, 2, 3, 4, 5, 6, and a 7, 8, 9, and this is a length 5 Renbon, so we need to have the 3 and the 7. We've got a 3 and a 7. And so the other two of 4, 5, 6 are over here. Because there's a 3, one of these is the indicated cell, so none of these are indicated. And because one of these is a 7, one of these is the indicated cell, and so none of these are indicated. So we can wipe out all of that and all of that. We know that these are 1, 2, 8, 9, just for the record. Okay, so there's a lot of things this can't be, because it can be 3, but it can't be 4 or 5. And it could be 6, but it can't be 7 either, because those would all point at something that is not the indicated cell within the box for sure. Okay. So we've got that. So what am I doing with that? Presumably it gets me somewhere. I do know there's exactly 1369 number along here for whatever it's worth. Oh, by the way, this isn't a 9, so that's never indicated. And so because that's never indicated, that means this is never a 3. So we can do a little bit more. So one of these is it. It's certainly a 1, 2, 8, 9 kind of business. So one of these is. I'm trying to look at things like, oh, am I supposed to say something about, like, can both of these really be 4, 5, 6, or does that somehow screw up this thing? But I don't think it somehow screws up that. Oh, row 7, right, row 7. This is also the indicator for row 7. So row 7, those are the only two that can be. Sorry, I read Emma's comment and was like, yeah, I did that. But Emma's comment was about the other row 7, not the row 7 that was in my head. Yeah, now this digit is only pointing at one of those two. That's a good point. So that's 4 or 7. Oops. Yellow or orange, apparently. That's not 4 or 7, but good try, Zeta. Let's see. Ambrose pointing out we can color these as... these aren't 3, 6, 9 at the very least, is what we're saying. So they're 1, 2, 4, 5, 7, 8, and they're not 7 because there's a 7 looking up at them from below. Oh, you mean for the columns? I see. This is a 7 or an 8. And these are this is an 8 or a 9. So this number is on this Renbon, no matter what, right? And so this number, because this Renbon has an 8 or a 9 on it, it needs both a 7 and an 8. So that digit goes there. So this is always a 7, 8. And this is a 6, 7, 8, 9, and I can catch up these. Those are the same digit. Okay, so this being here does wipe out that portion of this column because of that. Right. This 8, 9 also wipes out all of that. And so now one of these two is in. So all of these are out. And so that lets us come back and remove the 8 from this cell. And this is also a 1, 2, 4, 5. Just for the sake of it. One of these two is definitely a 3. I don't know which one, but whichever one of these is in, there's a 3 in the column. So we've got that. Right. This is never colored because the 7 points up, right? Agree. I'm trying to understand that this isn't 2 or 4, but I don't quite think I understand that. row 3 index, right? So this is an 8 or a 9. Agree. And not that one. There's no like weirdo overlap between these, is there? I don't think so, but who knows? Oh, are these equal? I was trying to decide if I knew they were equal or not. I convinced myself I didn't know that they're equal, but Ambrose thinks we do know they're equal, so that probably means we know they're equal. They are equal. Yeah, we know it by indexing. Wow, that's really weird. Yeah, this is position 8 for both of them, and this is position 9 for both of them. That's crazy. That is a completely psychotic deduction. Uh, uh, oh, right. If this is 2, we make both of those indicated, so we can't do that. I see that problem. And if this is 4, the problem is much more subtle. If this is 4, it means we're indicating both of these, which has the problem that they both become 1, and we're not allowed to have 2 indicated cells both contain 1. So yeah, that is quite subtle, but I agree. No quilt today. Proof that you've gotten sleep. I mean, sleep is good. Uh, uh, oh, this cell can never be shaded. There's another easy one. If this cell is shaded, it would make both of those 2, right? So that's another cell I can unshade. Uh, uh, and therefore this isn't a 5. And so therefore it's a 1. And we can bring out Zach for our 1 dance. Woo! Boop-boop-a-doop! Wah! Boop-boop-a-doop! Wee! Ba-doop! Boo-doop! 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 Wah! Thank you, Zach. Thank you. I love that this puzzle is exactly what I thought it was going to be. So that is truth in advertising and all that. So no 1 down here, no 1 over here. No 1's allowed to be in shaded cells anymore. Let's see. I know one of these is shaded, so this is not a 4, is what that is saying. So this is a 2, 5, or 8. If this was 2, it would say that's shaded, which is also what it would say by the box. I do know this is a 4, 5, 6. I don't understand row 1, column 4. Sorry, row 1, column 4. I was thinking row 4, column 1. Row 1, column 4, just not a 2. Yes, agree with that. Is a 4 or a 5, which now means one of these 2 is. Therefore, not that one and not any of these or those. And so it has to be a 5. If I did that correctly. Actually, maybe I want these to be yellow. That might look better. Do we like the yellow better? So that's a 2. These are out. One of these is in. So this is not a 6. It's a 7, 8, 9. So these are a legitimate 7, 8, 9 combo. That is a 5. No 5 over down there. There's a 5 over here somewhere. Sure. It's an X in one of these two cells. This 5 indexes something. I should probably mark the thing that it indexes. Uh, 2 and 8 are still the indicated cells, and this 2 and 8 means that's never the shaded cell. This is now just known to be a 4 by the indexing, chat points out. Okay, so this is now a 6 or a 7, but that's what we already knew, actually. So these are actually 3, 6, 7 exactly. So this is a 2, 8, or 9, which is, in fact, funnily enough, what was already known. This is the 4th in the box. Good. So there's a 4 over here somewhere. This is a 3, 6, 9. Just for the record. Hey, Qodec, how are you doing? One of these is a 2. So these digits are at least fairly large because we have to have a 6 or an 8 on this. So this is not the most profound pencil mark I've ever made, but these are certainly from 5, 6, 7, 8, 9. This is a 2, 8, or 9. If that's a 2, that would be a 1 because of the no 3, but I don't see a problem with that immediately. Right. I certainly can't have a 9 on here because if I have a 9 on here, I break this triple. That's true. But we could do 8, 7, and all would be forgiven, I think. I was trying to think about the relationship between these and that, but I don't think I know that quite yet. Yeah. The from puzzle from the distant past. I could imagine that this either took forever to set or that you set it in 30 minutes. And I would find both completely believable given the nature of the rule set here. And given that I know you don't usually set with a solver, I don't think. So I'm guessing you did not code a solver for this. Okay, people keep saying this can't be 9. It took a long time. Yeah, it's like it's going to be one or the other. If this was 9, that would be 9. If this was 9, that would be 6. If this was 9, that would be 8. All of this looks fine to me. Oh, if this is 9, that would be 8. This doesn't have anything to do with the constraint. Yes, if this were 9, that would be 8, and then this would have no value. I see. So this is 1, 7, or 9, just so that we're clear. 7 and 9 seem marginally more likely, but what are you going to do? Oh, not 9 again for the same reason. I saw it this time in less than an hour. Let's see. Yeah, so this cell is now right, and so therefore this is the only one that's yellowable in the column. And therefore this is a 9. So that's a 9. That's a 2-8 pair, so that knocks 8 off of this over here. That is the one that was the 3 up here. This is always a 4 or a 6. Yeah, that 4 or 6 all works out. Still got something with a 7, 8 over here. One of these is definitely a 6. Oh, column 7's indexing is done, so we should probably mark that. Which indeed also indexes that as the 7th, which makes that the 1 and the 2. Makes that the 8 and the 2. That 8 indexes this cell. Which indexes that cell. Okay, and so we either have those two are yellow. Well, this isn't a 9 anymore. I'm at least prepared to say that. This is a 7 now. We can de-ketchup these, by the way. These aren't 6 anymore. These are small, and they're not, and they don't include 4, 5, and 6. So actually, these are quite small, because I can't do 7, 8, 9, or anything like that. So that immediately makes them be from 1, 2, 3, 4, 5, 6. But if I include a 6 or a 5, then I break this cell. So these are in fact only from 1, 2, 3, 4. And they indeed definitely contain a 2 and a 3. So there's no 2 over there. In fact, the 2 is just always there, right? Because neither of these other cells seem to be able to be a 2. One of these two is a 3. I don't know which one. And then we've got a 1 or a 4 there to join them. One is placed in box 2 is a very smart spot from dweb because you can't repeat 1 in yellow. I probably should just mark the yellow boxes just for fun. Okay, so this one, not 1 for sure. This one's not 7 or 8. That was fun. Okay. 9 is placed in the yellow here, Laura points out. So no 9 in there or there. What are these digits? They're not actually 7 or 8. These are 3, 4, 6. So this is not a 4 or a 6 either. Oh, and that's a 3, 6 pair in this column randomly. So this isn't 3 or 6. Oh, right. This just is a 6 because of this. So that makes that a 6 by Renbon. Makes that a 4. So the one of these that's yellow can only be a 2 or an 8, just for the record. The one of these that's yellow I probably should think about, but I don't know if I want to just yet. There are a lot of 2s looking into this box, making that definitely a 2. Okay, so the one of these that's yellow is an 8. So these aren't 8. 8 is the only remaining digit that's left in the yellow space. So that one's not an 8 or a 2. That's a 5 or a 7. So those are a 5-7 pair in yellow, making this a 3 or 6 in yellow. I feel like I'm short a yellow square. Where are my 3, 4, and 6 going? Ah, right, it's these. Right. Okay, so these are 3, 4, and 6. So funnily enough, the yellow 4 definitely sees this cell, because the yellow 4 is either here or here. So this is never a 4. Okay. Ah, right. This 8 looks up. So there you go, 7, 8, 7. So that 7 actually gives me both of the remaining yellows. Gives me both of the remaining non-yellows. We can lose that now. So that was indeed the 3rd. That was indeed the 6th of these. That was indeed the 8, as previously noted. This we know is a 3, 4, or 6. It's not a 6, so those are a 3, 4 pair. So that one's the 6. That's a 3. That 3, 4 pair sees that cell, so it's a 1, making that a 3, making that a 4. 5, 9, 4. I liked that. That's 7, so that's 5. I do enjoy like this kind of like doubler-esque puzzle where you get like weird remote pairs and triples and corner marked things, and it does all sorts of very weird stuff around the grid. And so now we just hit the mark button and hope that everything works, and we'll probably be pleasantly surprised, hopefully. 6, 7. 1, 2, 7, 3. We'll remark just for fun. And then we'll Sven, and Sven will solve the puzzle for us. Excellent. I liked that a lot. That was like exactly what it looked like it was going to be on the tin, where it's going to be like, there's going to be a bunch of really weird off-the-wall kind of indexing deductions, and then there are a bunch of weird, really off-the-wall kind of indexing deductions, but all smooth and fun. A neat puzzle all around. Yeah, this feels like this would be nightmarish to set, because no matter what, you're going to accidentally have something that's forced that you really don't want to be forced, and you're not going to notice, at least if you're like me. And then it's going to turn out the puzzle has been broken for an hour and you didn't notice. And you have to rewind and then do it all again, and et cetera, et cetera. All right, I'm going to take a quick break and come back, and I think we're going to do whatever puzzle is next in my my queue of doing my own puzzles. I think it's Frack, which I think I might hate. So if you want to see Zeta complain about past Zeta steps, that might be coming. So see you all in just a moment. All right, welcome back. Well, good news or bad news? It was not Freck that was next. It was something I have absolutely no memory of whatsoever. So I know I didn't publish it anywhere, so that's something. Okay, so let's read the rules carefully to this puzzle that apparently Past Zeta thought was a good idea. This grid is home to 5 islands. Each island is made up of 6 orthogonally connected cells. Islands are separated by moats containing water, which may have any number of cells. 2 islands may not share an edge, though they may share a corner. Each island contains the digits 1 through 6 once each. This might be like the OG Zeta puzzle that contains these arrows doing something or other. Each island contains the numbers 6. The moats contain no digits. Digits may not repeat within a row or column. So let's see. How many digits are we putting in here? This is a 7x7 grid. What kind of psychopath was I to make a 7x7 grid? Okay, so so there's 30 cells with digits because it's 5 islands of 6 cells. So 30 cells contain digits. Yeah, okay, so that makes sense. Arrow clues give information about the size of the moats. If an arrow is in a moat, the number of cells in that moat is placed in the first island cell in that direction. Okay, because you can't put a number in a moat cell. I suppose that makes sense. If an arrow if an arrow is on an island cell, then the digit contained in that cell is the size of the first moat in the direction the arrow points. Okay. Clues outside the grid are skyscraper clues. I admit I did not see that sentence coming. That was a real twist. There. If you imagine that each island is a building whose height's given by the digit it contains, then the clue gives the number of buildings seen. Water tiles are never seen. Row 7, column 4 is land. Yes, that is elegant. Okay. So who made this? Yeah. I mean that's kind of the fun of doing my old puzzles is it's like would I really do this? Okay, so what on earth? Quite nice to emphasize that cell with arrows so we can't miss it. Okay, so this is land. It's part of some land. Can we use some totally inappropriate colors for water and land? Are you suggesting we do a Simon and make the blue water like we're Buster Bluth or something? Is Buster his name? I think it's Buster, isn't it? Yes, this must be land, because if this is not land, Emma points out, then it would be placing the size of it off the grid. We shouldn't do that. Okay, I'm going to make these the orange island. Sorry, must be water. Sorry, not land. Sorry, water. The other one. So yeah, its size is here. Okay, so Earth was once purple. Like Earth water was once purple? Okay, so if I guess the like thing to think about is how this interacts with so these can't well, one of these is definitely land, but oh no, they could both be land, right? At least one of them is land because this land mass has to grow. This is a very intuitive rule set. Let's see. As I recall, I'm starting to hazily recall, I think I made this as an example puzzle for a larger puzzle that I didn't even know. Apparently, Earth water used to be purple. Good to know. Good to know. We could make this water purple. That's fine. Classic Earth water. Uh, okay, let's see. It's 3 from that. So there's at least 4 land cells in this column because of the 2 and the 3, I guess. That doesn't seem very useful. This points all the way up the column, so it seems like it could be anything. This cell is always land, right? No. One of these is land is the right statement, right? If both of these are water, that definitely breaks. But it could go either direction, I think. Which way it goes. Yeah, so there's a border. We could draw in the border. Let's do that. That sounds productive, or it sounds at least like it provides the illusion of productivity. We only see 1 in this direction. So there's like a large number, or there's just almost no land. This 3 and this 3 could mean that there's just 1 island down here in totality, but I suspect that's probably not the case. Yeah, we can also put a border here while we're at it. This is not on LMD. Read into that what you will. Yeah, the 4 land cells in this column is interesting. Okay, so these are certainly not both water. Is there a problem if these are both land? I don't think there's a problem if these are both land, is there? If land, they're a 1-2 pair? Is there a reason the water couldn't go up? I feel like I'm supposed to be thinking about whether these arrows can be pointing at the same body of water that this is. Which I think they can't be, right? Is the because this contains the size of that. Uh 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 yeah, so whatever happens, this moat can't be seen by either of these arrows because the size of this moat is here. Is I think what Selena is saying, which is what I was trying to think about. Let's see. This is a weird idea. Isaac's suggesting I create a puzzle with this rule set now. I think the better setter than I am now would probably not have ended the rules with the clues outside the grid or skyscraper clues if I were to take a guess. Do I know? Oh, you're saying this can't be one of each. Okay, so if this is one of each, let me just imagine that this is one of each. Yeah, this can't be one of each. Right. If this is one of each, then I've put the same number twice in here because if either of these is water, then it puts its size here. But then the other one will be the size of that water and will put its size on itself. So yeah, so they have to both be land. So we can at least grow our land like that. The sequel must contain row 7, column 4. That is clearly an integral rule to the whole thing. Yeah, so both of those are land. So there's at least some water in each direction over here. This water's size goes there. This number can only be a 6 if this goes 4, 5, 6, as if that is somehow useful. But I do know there's at least some water over here and some water over here. So there's certainly, like, does something go wrong immediately if I make, like, as soon as this is land, then that's water, is what I'm saying. And as soon as this is land, that's water. But I don't think there's something that immediately goes wrong if I make this the water and then let that be land. If this is land, this can't be water, I see, because the size of this moat is already here. And so if this was land, it's part of the same island. That would be a problem. Oh, yeah, this just definitely... Sorry, I looked at the wrong direction first. This just definitely isn't land, because if it was land, it would be the size of this boat, but that's already there. Okay, and so Emma's argument first, then my argument. This now can't be land, because if this is land, it gets the size of the same moat that's already there. So this is also water. Okay, so now we know there's a land over here somewhere, but the land that's over here somewhere is not part of this island. Because of that, is interesting. Okay, this number is at least 3 now, is maybe worth marking. Oh, also, there's only a maximum of 1 additional water in this row because there's a skyscraper 3 here. Is it a problem if both of these are land? I don't think so. Yeah, there's at least 1 land over here, at least 1 land over here. We could, of course, do something like that or like that. Yeah, these can't both be... right. These can't be row 7's island's land, because this island already has the size of this moat on it. So this island can't possibly make it into these 2 cells. And therefore it always grows left. I agree with that. And therefore, by the bit about water, this is always water. Excuse me. Oh, I could make all the water. I was wondering if I should make each water a different kind of bluish color. But I guess I don't know if this water is the same as that water. So I guess maybe I should just try and make all the water purple. But yeah, I don't think I know if this is the same mode or not. I do know that if this is land, it contains a 1. Oh, no, it's definitely different, right? It's definitely different because of the arrow, right? This is the size. I could even flash this. This is the size of the purple mote. I'm going to make this the blue mote. This cell is the size of the blue mote. Uh, uh, Me too, Isabella. Right. We know there's a body of water over here. And we also know this island never enters this row. So because of this arrow, one of these two is water. Because of this arrow, neither of these two is part of the orange island. And therefore, I still get at most one more of these down here. So this always goes here. Is what is being claimed. Can I possibly get away? I was trying to decide if I could possibly get away with making like a flash or something other than a flash, but I don't think I can easily. The size of this goes somewhere. Two bodies of water in row 7. Yeah, one of these two is water for sure, at least. But they could both be water, I think. Right. This can't be land, Carl spots, because if this is land, it would be that same. It would be an orange-blue cell, which there's already an orange-blue cell in orange. So this is always water. Okay, and this is going to point at like a sky blue mote over here somewhere. Do I know for sure that mote isn't of size 1? I don't think so. Row 6 needs at least 3 land cells because there's a 3 skyscraper now. Right, all right. So these are both land, and therefore they're both part of another land mass that's not orange. So it's going to be a part of a green land mass, which is going to force this to be water, because otherwise my land masses touch. I'm going to make this part of the light blue water. So this is flashed with light blue now. Oh, sorry, that's not where that goes. Looking at that. One or two. Oh, right. This is 1 or 2. Sorry. I thought you were saying this is 1 or 2, and I was very confused. Yeah, right. This is either 1 or 2. Okay, and this orange needs to finish. It finishes there. So orange is done. And that means that this blue grows at least 1 and this purple grows at least 1. And this is water, but I don't know if what color of water. This is certainly not a 1 because it's bigger than the green cell that shows up over here. Oh, this can't be 5 due to the column skyscraper. You're right. There's a 3 down here. So this can't be a 5. I agree with that. So this can't be a 4. Purple is now at least 4. I agree. So that's not a 3. Oh, this being a 1 or a 2 also put pressure on this skyscraper, right? Because now this being a 6 is going to require a 1 and a 2 specifically. Oh, yeah, this is also the size of purple, right? This I should purple flash because it's also a 4, 5, or 6, right? Fortunately or unfortunately, that actually is very useful because now these two are the same digit, and so they must both be 4. We can bring out Zach for the 4 dance. Thank you, Zach. Thank you. So getting 5 out of this cell was very potent. So this is more than 4. So this is at least 5. The moat is done, right? That's true. So now this moat is bordered by water over here, or sorry, by land. Sorry, this is a moat by land that is either green or it isn't. But in any event, this cell is larger than at least 2 things. So this is at least a 3, just because it needs to be bigger than both of those. Oh, sorry, no, one of these is definitely land, right? I don't know which one, but one of these is definitely land because the green needs to take at least one of these 2 cells no matter what. So there's actually at least 3 cells over here. So that actually gives us a 5, 6 pair. So that means that these are from 1, 2, 3 now in finishing orange. So in fact, actually, 3 had better be the size of blue. To make that work. This is certainly a new land mass over here. I might as well give it a color like pink, my favorite land color. This is a new water body. So this can be, let's see, what other colors of water can we have? We can have this like Easter color water. And this Easter color water has to be separated over like that. So this pink goes up here like that. Having done that, this is a 3 because it has an arrow pointing at it. It's possible that this color scheme is not going to work well. There is some chance of that. I probably am supposed to like repeat colors or something. I don't know. But it is useful to be able to mark, at least for sanity, that what color or what moat these things are caring about. But I probably no longer need to mark these moats, for example, now that they're done. So I probably can just make these be blue again. I could make this blue if people would like. Let's see. So this cell, if it's land, creates a problem because if this is land, we know both of these are land already. And so this would be land pointing at a 4 cell moat, but it can't be a 4 because there's already a 4 in the column. So this is in fact always water, which actually forces the green island up here. We know these are land, and it's probably some as of yet undisclosed land. So we could make that like a dark green kind of island. Is 6 an orange known? How? The last row has a skyscraper, so that makes this a 1 and a 2, points out Carl, which lets me finish this moat. It was the skyscraper that we were doing there. Because if this went 2-1, the skyscraper would have been a 2 and not a 3. 2-1. Oh, it could have had a 6 over there. Oh, you're right. Right. This could be land as long as it's a 6. Right. Yeah, sorry. It could have gone 2-1-3-6, right. Or even 5. Yes, even 5. This skyscraper tells me the order of the 5 and the 6, right? Because if this is a 6, I'd need all of this to be land. And that doesn't work because there's already a 3 in pink. So yeah, if this is a 6, all 3 of these would be land, and they would need to be they would need to be a 1, 2, a 3, and a 4, but pink already has a 3. So that doesn't work. So this, in fact, is a 5, and that's a 6. Row 5, column 7. Now also 1, 2, 3 by row. Yeah, because right. So this digit is smaller than 5, but it's not a 4. So it's a 1, 2, 3 is D-Web's point. And I agree. We do still definitely need to land up here, no matter what we do. It's possible we could get away with this not being land, but it feels like it would be very strange. Oh, this column needs a 5 and a 6. Because we've got a skyscraper of 3, and we're looking at a 4. That is a lot of additional land. I suspect we're going to have a 3-size moat up here. But who knows? I don't know yet. If this is blue, though, that breaks by Selena's math. Because we, again, we need a 5 and a 6. And this 2 here tells me the 5 and the 6 aren't the only other land cells in this column. So there's 3 more land cells in here. Wait, is that? Yeah, this would be the 5th green. No, maybe that's okay. Sorry. Yeah, we can corner mark 5, 6 in here. I think that's reasonable. That one's not the 5. That one's not the 6. Oh, and this one's not the 6 either, actually, because we know there's another cell. So yeah, so one of these two is a 6. Oh, right. I was proving the water couldn't go up. Right. I was started out trying to prove the water couldn't go up, and then thought I was proving the land couldn't go up. If this is water, then there's a big problem, because if this is water, this land mass goes up. And so now in particular, all 3 of these are land, but that's way too much land for this one island to have. So this just can't be water. This is land, and so it's lime green, which does make this a 1, and makes this blue, because these two are different. They can't join without making a landmass that's too big. So green grows over here. And now this we've known to be land the whole time, so this is green. Oh, right, this can't be 5 anymore, right? Agree with that. So one of these two is 5. Right. If this is water, both of these are land, is 57 Thorns Point, and that's a 7 size land. So this is never water. This is always land, but it's a different land. Can make it... Oh, I don't have like an earth tone. There we go. We'll go with that color. It'll be jungle. So do that. Okay, so this is a number that is a 1, 2, or 3. And yes, now we have all 5 islands. Good counting. This is not a 1. Right. And this also is a number that's smaller than 5 that's not 4 or 1. So these are a 2, 3 pair. I agree. And we do still have 2 lands over here. I don't know if this is a sign I'm a psychopath, but this puzzle's growing on me as I do it. Let's see. As I slowly unravel what on earth is happening in this bizarre rule set, I'm going to... now that I feel like this is kind of intuitive, I'm going to try and do this over here. Maybe intuitive is the wrong word. Row 4, column 7, or row 1, column 6 is a 1. Zamak has a request for larger moats. Right. This can't be the 5 anymore, because if this was the 5, then we'd need to have the 6 there, and that's too many lands again. So this needs to be the 5. And so one of these two is a land, and it's a 6. And it's just a question of, is it a 6 associated with this, or is it a 6 associated with this? We have this annoying possibility that the land does something like that, I think. But how big can this water possibly be of size like 4 or something? I feel like it can't. This is a moat too large error. So if this is land, then all of these are water. That's definitely water. Right. Wow, that's weird. But yeah, but completely correct. Yeah, if this is a 6, then now this number is a 1, 2, or a 3, except now this water definitely includes these 4 cells. Because this being a 6 has sudoku implications on this cell. So this is not land. And this is land. It's part of our reforestation land. Okay, so this now is, let's see. Okay, well, that's the 6. I'm at least willing to say that much. Yeah, are we positive that this isn't land? Oh, yeah, this definitely isn't 3. I definitely believe that, because if this was 3, it would be way bigger than 3. Sounds bad. Yeah, this looks to me like it can be 1, 2, or 6 as my feasible things. If this is green, it's a 6. Yeah, I think it can be 6. I don't know how this relates to the. This may well have been during the chaos deconstruction era. I don't. I don't write. I mean, like I said when I started to do this, I was like, I don't remember this puzzle at all. I have very hazy recollections, but this could very well have been me deliberately riffing on chaos deconstruction stuff. Oh, right. It being 6 breaks because if it's 6, then that would need to be a 6 and it's not. I see. Thank you. So this is only a 1 or a 2. Oh, it could be a 6, but not the way I had described. It could be a 6, but something like that 6 or something. Uh, right. Okay, so but these aren't both water is the point, because if those are both water, then it breaks. So at least one of these is land. Oh, sorry, exactly one of these is land, right? So there, I can put a border between them because these aren't both land, and they aren't both water, is what we're concluding here. So there's definitely a break here, regardless. Uh, uh, I'm going to pencil mark this just because it can't be that many things. This can't be a 1 either. Is this cell only a 2 or a 6? It's not a 1, 3, 4, 5. Yeah, this cell's only a 2 or a 6, which feels weird. Uh, oh, this can never be 1, right? This being 1 just no longer works at all. Because if this is 1, what is it pointing at? That would have to be land, and that would have to be land. So yeah, this is never 1 anymore. Yeah, row 7, column 7 can be 6. I agree with that. Uh, oh, so this is a 2-6 pair. So now this cell is a 1. No, it's not a 1, 2, 3. This is a naked 4. I think this cell is now a naked 4. Uh, Uh, Past data certainly made some setting choices. This is true. This is true. I wasn't always in the neutral good category of the setting diagram. I did some time in the chaotic evil setter quartile. Uh, there very well could be a naked moat cell. Who knows? Uh, okay. So that's a fascinating issue. From 57 Thorns is correct. If this digit is a 6, then we have a problem. So this being a 6 automatically makes this water. But the problem with that is that then this cell can't be a 1, 2, or a 3 because of sudoku. So this isn't a 6, it's a 2, which makes that a 6. Uh, which makes that a 3 and a 1. Uh, yes, there are 2 pink land cells in this column now because the we knew there weren't 3, so there's 2 of them and they're pink. Uh, this is 2. Thank you. Uh, uh, okay, so the remaining digits here are 3 and 5. Uh, uh, so if this is water, then those are both 2. If this is land, uh, uh, oh yeah, if this is water, that destroys pink. Yeah, this being water just obliterates pink. Because if this is water, then it forces this green up here, and now I can't fit my obligatory number of cells in this column. So this isn't water, it's land, uh, which makes it the 3 or 5 that it needs to be. Uh, if it comes over here, then it's got to be a 5, but yeah, I could just barely make it here and have this land do that, and that would probably be okay. Oh yeah, dark green now needs this cell, right? If dark green, thank you. Yeah, if dark green doesn't take this cell, we now have a problem that dark green is not getting to be large enough. So now dark green takes that cell, which makes this be water for sure. Means dark green certainly takes this cell as well. Uh, one of rows 5 and 7 needs one. Uh, needs a 6. Let's see. Emma says if this is water, we run out of space. Space for this island. Yeah, I guess we still got like a faint possibility that this comes here and forces the top hat region here and this over here, which would force that over there. So what are the numbers in pink in this column? They're not 3, 5, or 6. And they're not 1 and 2. So there is a 4 in pink in these cells, and it's the highest one. So the 4 in pink is in one of these two cells. And then there's a 1, 2 as well. So this cell is never land, right? If this cell is land, it forces green and green to touch. Because if this is land, it forces this to take all 6 of those cells, but it also forces this to take those 6 cells, and that doesn't work. So I think this is just always water. Uh, 2 forests left, right? Well, I mean, forest never takes both of these cells at the very least. So it's a question of forest take both. Forest either takes this cell or it takes both of these. See, Playmaker is saying one of these. Oh, sorry, row 1. Oh, yeah, what are the cells pink can possibly take? Pink definitely takes 2 of these 3, plus these 2. Oh, so these cells are just pink, right? That is, I think, what Playmaker is saying, because there are no more cells I can get. I can only get 2 total pink cells in here, and so I need 2 pink cells over here. So that's good. So we're almost at peace. These can't both be in. So yeah, I think what Emma's been trying to communicate to me for a bit is to count cells. I need 3 more cells in these 2, and it's a maximum of 1 of these, a maximum of 1 of these, and a maximum of 1 of these. And so this is always part of dark green. I couldn't quite parse Emma's argument, but now that I have seen it, I understand that I think that's what Emma was telling me before. because these can't both be in. So if I'm counting the two sort of weird green colors together, these can't both be in. So it's at most one of those, or at break pink. Those can't both be in, and that one can't both be in. So that means that I need one of each of those groups. And so there we go. So we have that up there, which does make this a 1. Isabella is very glad I did not make the 14 by 14 version of this with nine cell islands or something. Okay, and now the 2 needs to see 2. So now this isn't land. Now this is water. I did hear that Bells was hoping that there would be a larger one here. This was certainly a past Zeta puzzle. Agree. There are definitely things here. So this is now Kelly Green. Welcome back, Kelly. Like that. So now this is a 5 and a 3. This is a water. So since this land is not done yet, that is land. And now this has got to be water. And these 2 are both pink. This has got to be water. Like that. So now we hunt for naked singles. That seems to be a naked single 6, which now resolves the order of the 1-2. Oh, funnily enough, the order of the 1-2 is doubly resolved because it's resolved by the fact that the 6 came down in 2 different ways. Funnily enough. Okay, so these are a 1 and a 4. We actually knew where the 4 went if we paid close attention before. So these are a 2, a 5, and a 6. That one's not the 6. That one's not the 5. This is a 4 or 5. These are 2, 3, 4, 5. Okay, so this is not 2, 3, or 4. So this is just the 5, which makes that the 4. So now this is a naked 2, and that's a 3. And 5. And there we go on a Zeta puzzle of all time. It got more intuitive as I went along, but I don't know how much of that is cope from doing it. It certainly was not a very natural puzzle to get a handle on to start. Yeah, somehow I think my like starter easy example puzzle ended up being like a 5-star puzzle for the advanced puzzle or whatever, like very KNT style version. Given land was not used. I think we needed the land because so I think when I set this, I think I believed that these 3 arrows forced that to be land, but I think it turns out not to be the case that these 3 arrows forced that to be land. And so I think that like at the end when I understood what was going on, I think I decided that was what we needed. Yeah, that I think there are some ideas here that one could use to make a good puzzle that would be LMD worthy. But I think this is just sort of the beginning, and I probably would not pick Skyscraper. I'd probably pick something more intuitive like Renbon. If no one caught that this could be, yeah, that's true. Yeah, we did very nearly miss this possibility. Yeah, this does seem like an incredibly difficult thing to set without making a logical error. Like that is the thing that was most occurring to me, is like how many things I was tempted to say that I caught myself being wrong. This is a quite cursed thing. Excuse me. Make it counting circles. Oh, that sounds fabulous. Uh, has someone done a counting circles deconstruction? I don't want to see it, to be clear. I don't want to do it, but it sort of feels like that has possibility for like true psychoticness, because some of the counting circles won't contain a digit, so you can't just count the circles and then basically be done the puzzle. Alrighty, I'm going to take a quick break, and since I promised it before, when I come back, we're going to do frac, which I think I'm going to really have notes about, but we'll be back in just a moment. All right, welcome back. So before we dive into the puzzle, which I seem to recall there being something that I was really proud of at the time that I think I'm now going to think was horrendously bashy involving this area. But why is it called frac? So this is a somewhat involved story. Not that involved, but basically in Battlestar Galactica, the TV show, which was originally around in the 70s when I was not alive, and then was brought back in the early aughts when I was alive. Spoiler. They used frack as a curse word because it was originally on network television, and so they couldn't use like real curse words. However, quite upsettingly to me, whenever they spelled it F-R-A-C-K, which if you're going to make a curse word, it had better be 4 letters, so I always thought they should spell it this way. And I think in the new version of the series, they did spell it this way. But anyway, the new version of the series has a gimmick where all the paper in the universe has the corners cut off. So if you look for screenshots, you can see this. And so the sort of shape of this line around the outside was my motivation for so naming it. And this is an idea that I had that I could not get out of my head once I had the idea, which is to make a chaos construction region sum lines puzzle. So this is a chaos construction region sum lines puzzle. So these are traditional region sum lines, which have the same sum in each of the regions they pass through, except we don't have regions. We have to find those ourselves. And we also have the circles, and to the circles count the number of digits on that particular segment of the line within the region. So I will say that this puzzle is unique without lots of the clues here, and that the original version I made had fewer clues than this. But I decided to be slightly more humane to help with the chaos construction part at the end, which did greatly upset Vebi, who really liked the version that was minimally clued. Okay, so let's start with this big long line on the outside. What does this big long line on the outside sum to? So this is a sum to, so 45 times 4, which is 180, except if I do that, I've counted these numbers twice each. So I have to subtract 12. So I'm looking at 168. Who wants to do a prime factorization of 168 for me? Let's see. That's the order of the smallest simple group that's not alternating. So that probably means it has a 7 in it. Let's see. How many 2s go in? Is there like a 2 cubed? Just some 3s or something? Let's see. Alpha, will you... let me ask Wolfram Alpha. 168. Okay, so it is 2 cubed times 3 times 7. Okay, yeah, so 2 cubed times 3 times 7. Oh, no, I need to count them all 0 times. Oh, sorry, yeah, you're right, sorry. That was if these numbers were on the line. Sorry, no, these numbers are off the line, because I was counting them twice, and I need to count them 0 times. So it's actually 180 minus 24, which is 154. So 154 seems to be 2 times 7 times 11. 156. 156. We'll get there eventually. We'll factor the right number someday. Don't worry. Seems to be 2 squared times 3 times 13. Okay, so this region sum line has some number of regions in it that's at least 5, because of region shape things. And so we need to look at divisors of this number that are... oh. Why did I write 164? So 156, sorry. I wrote the right number, or the right factorization, and then didn't write the right number. So we need to know what divisor we're going to look at. So we need divisors that are certainly at most 45. So the largest divisor we have to consider is 39. But then we also can look at this here and see that we've got something of length at least 3 in this row. So that's going to be at least 12. So that's like a 3, 4, 5 at minimum. So 39 is the biggest. 12 is the smallest. And so let's see. What else do we have? So 39 is the largest. And then we could do 26 as well. We could do 13. However, if we don't put the 13 in the sum, then we're going to have 13 segments. And 13 segments is, I think, going to be a bit of a problem for a line whose length is... What is the length of this line? 7 times 4 is 28 long. So technically we could do 13 times 13 sums to 12. But 13 sums to 12 is going to be rather problematic. I believe, for the reason that we would have to here do a 3, 4, 5 somewhere. Let's do a 3, 4, 5 and then a 5, 7 or something like that, maybe, possibly. I'm contemplating numbers and reality. 13 sums seems visibly impossible. I'm trying to decide why it's impossible. Uh, uh, but yeah, we have to decide which of the three options it is, because we've got 12 sums to 13, 13 sums to 12, or 6 sums to 26 are my options so far. I guess I can look at what these numbers could possibly be. Maybe that's worth thinking about. Oh yeah, we only have 9 regions. Right. That's a good point. You can't have 13 different regions touch the border because of that. Yeah, the geometrically you can't have more than 9 because of the regions touching the border. So I agree with that. So now we've got to decide, is it oh, that also does 13 times. So that just forces it immediately to 26 times 6 or 39 times 4. 39 times 4 also seems quite problematic because there's more circles than that around the outside of the border. So we can't do 39 times 4. So yeah, the fact that we have 5 circles tells us that. So we just know the sum for this line is 26. If I pull out my little pen, I can write that. So the sum of this line is 26. And there are 6 of them in total. So let's give each of these its own color. It's my first time getting to use this nice color palette where I've actually got 9 distinctly colored regions. Okay, so the size of the region certainly is at least 3 if I'm getting a sum to 26, right? Even 3 isn't good enough. I've got to get to at least 4, right? And 7 would be too big. So these are all from 4, 5, 6, right? So this is just a 5, I believe. Let's see. Okay, so this is a 5. We can bring out Zach for the 5 dance. Boop boop ba-doop. Whoa. Boop boop ba-doop. Whoa. Ba-doop 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 ba-doop. Thank you, Zach. Thank you. Yeah, we do have one unclude region here somewhere. That we have to figure out exactly where we're going to put it in. Okay. Yeah, you can technically do this with a 3x3 inside, but that's certainly not relevant within this puzzle. But yeah, we're like right on the border of geometric obtainability or whatever. Okay, so these numbers in total sum to what? They sum to 45 minus 8. So that is 37. And yet yellow plus blue itself needs to sum to 52. How much larger is 52 than 37? It sounds like it's 15 larger. Sounds plausible. Okay, I do know all of these are yellow or blue. So I guess the question is, yeah, so I think I can creep blue down if I do this math carefully. So we've said these numbers in total sum to 37. And we're going for the yellow and blue region together, which certainly these are all yellow or blue, need to sum to 56. This did get a feature, yeah. So, like, what's the maximum that these cells can sum to? And so that would be 17 plus a number that's not enough, right? 9, 8, 7, 5. Uh, 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 that's the math I was trying to do, Josh, but I was trying to actually do it rather than just saying I was doing it. But this is this is 6 digits. Those sum to a maximum of 39. I believe, except these actually sum to a maximum of 37. Is that right? Because of 36. Because these could be 1, 2, 6, right? Uh, 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 oh, we can actually extend yellow. The other way is much easier just by cell counting, even, right? So if this was 4, then yeah, sorry, Josh is right. There's a much less mathy way to do this, which is to say, if this cell isn't blue, then this is 4 and this is 5, and that's not 5 cells. So always blue extends this way. Now, if this is not yellow, can we do the same thing? Not quite, right? That does push pink left. I agree with that. Yeah, just because pink is 5 is why. Remember that there is an additional region that we do not have marked, Isaiah. We only have marked 5 of them, and there's 6 of them. I could try and total these and just figure out how many things are left on the other one, but I don't think I quite can. Uh, 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 and just like thinking numerically, 4 is with 3 numbers that sum to 22, which unfortunately there's 2 options for how the 3 numbers sum to 22. As far as I am aware, so I don't think that's immediately helpful. Okay, so there's 28 total around here. That's 14. So there's 14 total cells left for 3 more regions. Right. And so if this were a 6, then at a minimum, right, 4 is the minimum. So the other 2 would be 4 and 5 at minimum. So this is therefore maximum 5. I agree with that. That makes sense. Uh, uh, it can't be a border above row 3, column 9 because of the 2 ways of making 22, says Carl. So it's 5, 8, 9, and 6, 7, 9. Right. And so these 3 cells can't possibly sum to 22 because the 5 and the 6 are both gone. So agree. So that cell's always yellow. Okay, well, we certainly now know that. Well, we might as well mark. We know that these are purple or yellow, right? I'm not squeezing another sum in there. And these are blue or yellow. Sorry, blue or pink, because we're not squeezing another sum in there. Because again, sums take at least 4 cells. So we can at least mark that sort of around the ring. Oh, this purple assuredly needs to slide at least 1 over here as well, owing to the fact that now we've got that kind of purple. Would 5 digits contained entirely in this row have a sum that was too big? Wouldn't that be 27? I think if this is a 5, I think it sums to a minimum of 20. No, not 27. It would sum to a minimum of 25. What's 3, 4, 5, 6, 7? 3, 4, 5 is 12, 25. Yeah, so yeah, this being a 5 would be restrictive, but not restrictive enough, I don't think. 9 column 6 has to be pink. We can't make all of this blue. Oh, right. That now is making yellow and blue both 5, right? The yellow blue menace is 9 total long. So that means there's 2 total yellow blue cells that stick out of this column. Right. That's the key thing. And so this is never blue. But also those 2 yellow blue cells, we know there's some. Because of the fact that these cells sum to 37. So the sticky outy bits sum to 52 minus 37, which is 15, right? So the sticky outy bits are from 6, 7, 8, 9. If these are both the sticky outy bits, it's a 7, 8 pair. If these are both the sticky outy bits, then we've got a little bit more flexibility, I think. That is, I think, probably the nicest way to think about it. Okay. So this 5 is never getting out of this row, for what it's worth. This is never getting out of its row either. Oh, I'm being told if these are a 7-8 pair, it breaks the blue sum. Let's walk through that. So if these are both blue, then they are 7-8 because of our previous bit about sum. But those sum to 15, so we'd need to sum to 11 and the remaining 2 or 3 cells. So we certainly couldn't do 4 and 7. So we'd have to do 5 and 2 and 4. And we don't have room for that. Oh, it's the pink sum, not the blue sum. Okay, yeah. So the that is a good way to look at it. So in this row, the things that are not pink 3 or 6 sum to 10. So I can't possibly make these two sum to 15. And so therefore this is never blue. Which forces blue up 1 over here. For sure, which forces yellow up 1 over here. Which then forces purple 1 over here, right? And we know that this is a 6, 7, 8, or 9. This is also row locked, though. But I think its row locking is less useful because we've got 29 total in this row from it plus these two. So the remainder of the row can still sum to as much as 16. Oh, wait, that doesn't work, does it? Because if I make this yellow, doesn't that make the remaining digit in this cell also a 1? I don't think that works. So if this is yellow, these sum to 15. The purple cells sum to 26. So together, that is 41. Plus these would be 44. That doesn't work. So yeah, so this can't be yellow either. And so now this is definitely yellow. In fact, this is a 6, 7, 8, 9, and is not a 6, and is now also blue. Okay, and that being not 6 means that's not 9. Oh, we actually know where pink lands now. Pink lands over there. And we previously noted that these two cells now add to 10, right? So if these two cells add to 10, this isn't to 7. And this is a 1 or a 2. Just for the sake of that. So these can now no longer be a sum to 20. Oh, no, it could be a 2, 7, 8, 9. I guess there's one way. If it's 2, 7, 8, 9, that would work. I'm being told this is not an 8. It would make that a 2. Oh, row 1, column 8. Sorry, this one, right. That one's not an 8 anymore, right? So this is either purple or green, or we've shoved the other color in here. The other color we know is at most 5 long. The only way... oh, right. We might as well mark, since we're doing a chaos construction, we might as well mark that this cell is definitely in the yellow region and this cell is definitely in the blue region. I agree. That is a good idea. Blue being 4 fails for some reason related to the sums and the 6. So the two ways to make 22 are 6, 8, 9, and 5, 6, 7. And both of them have a... sorry, 5, 6, 9? No, not 5, 6, 9. 6, 7, 9. Both of them have a... no, they can't, but this doesn't work. 5, 8, 9. 5, 8, 9. Right, we're going for 22. 5, 8, 9, 6, 7, 9. Okay. And neither of those is possible, right? Because of the fact that the 5 would have to go in the column with a 4, 5 pair. So, right, so this is never the 4. So this is the 5. Which makes that the 4 and makes my blue line extend 1 further. Okay, and so now we can figure out what this yellow sum is, probably. If I look back at what my notes were, they were 6, 7, 9, which is not... oh, sorry, this could be 6, 7, 9. Oh, it can't be 5, 8, 9, though. So this is 6, 7, 9. It's 6, 7, 9, and that's the 6. And so these are 1, 2, sorry, not 1, 2, 3, 1, 3, 8. And so therefore this is a 9. And those add to 15 like they're supposed to. All good. That makes that a 1. Which now makes it so that this is now green, because now I can't make a sum to 26 and 4 anymore now that this is a 1. So this is all green. And that's green. And these are some other color, yet to be fully appreciated, but some color. Let's see. These are, just for the record, 2, 3, 4, 5, 6, 7, 8. And what did we say the Audis sum to in this row? So this is 26 plus 9 is 35. So I can't make purple extend 1 more, or this cell is a 10, right? Because this is, if I just sum all the purple cells plus these, that's 35. So the other cells need to sum to 10. So this is always red. So that makes that a 4, and these are now 3, 7, no matter what, right? Because any other combination to 10 is broken. I don't know. Maybe I don't actually need the dashed grid. Maybe I can do this with lines. I don't know. We'll see. What's over here? These are 5, 8, and 9. Okay, maybe I liked the dashed grid better. That looks a little too aggressive for me. Okay. Okay, and this is definitely... oh, so the question is, if those add to 10, can these two add to 16? It seems like the answer is yes. It seems like they... oh, no, they can't. They can't. Because they would need to be 7, 9, right? And 7, 9 is not an option because red already has a 7. So if red doesn't extend, this is broken. So red extends, which does make this a 5. Uh, and there's a 7. So now we can do a little bit of Sudoku. There's a 7 over down here. So this is a 7 and digits that add to something. 1, 7, and 5 is 13. So we need another sum to 13 that doesn't use a 5 or a 7. So it's 4 and 9, right? I think this has to be 4, 7, 9. And these are 2, 3, 4, 5, 6, and 8. I think that sounds good. Okay. So now we have to try and keep track of what digits are actually left in these colors. So for what it's worth, left in red, we have 4, 5, and 9. Left in purple, we've got most things. 1, 2, 3. 6 and 7. Left in yellow. 1, 2, 3, 4, 5, 6, 7, 8. 1, 3, 5, 8. Left in blue. 2. No, not 3. 4, not 5, 6, 7, not 8 or 9. So 2, 4, 7. Left in pink. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And left in green. 2, 3, 4, 5, 6, 7, 8. 2, 6, 8. Okay. All right. I don't know what that does for me, but it seems good to have written in just for the future when I'm thinking about it. Okay. This line is a little bit interesting because we know it's just sort of like an arrow that doesn't have a 6 or a 9 as the sum. So it's at least vaguely interesting. Okay, so the kind of interesting thing actually is that we've got all of these line regions have to sort of make their escape onto this line because we can't get green out, or red out, or purple out, or yellow out without actually doing this. So this line, whatever the sum of this line is, it now needs to be makeable with some subset of 2, 6, 8, which means it's going to be even. And some subset of 4, 5, 9, which means we're definitely going to need the 5 and the 9, unless the sum is 4, which isn't going to work very well. So the sum is going to be like 14 at a minimum. And we can't do 18, actually. So yeah, actually the parity actually just tells us everything, right? The sum is going to be 14 because we need the 5 and the 9 to make it even. And if we add in the 4, it's too big. Right? Do we agree with that? I think that's right. So the next sum is 14. Okay, that was the step I thought I remembered that I was going to hate, but actually it worked out quite nicely. It was not as horrible as I remembered. I thought it was quite bashy, but it was not actually that bashy. So this digit here had better be a 3 or a 4 only, because we're summing to 14. So this cell's not green, that's for sure. It's some other color. I can draw in my border with the thing there. Because the green 3 and 4 are over here. I guess I can also draw in like these borders if I'm going to commit to the dashed grid, which I suppose I'm going to. One more over here. Okay, so I know that there's going to be a 6-8 and a 5-9 in here somehow. I'm being told it's also not pink. Oh, I just can't make a sum of 14 in pink, can I? Yeah, it's just not possible. 1, 3, 6, 9. If I use the 9, I'm doomed. And if I don't use the 9, I'm even more doomed. So, right. So this is also not pink. Which I think means this is just a new color, right? There's nothing left that this could possibly be, I don't think. So we can just go ahead and make this orange. So yeah, we're gonna get green. Green could escape like that, and it would be okay. We do know that green is gonna chuck a 2 into this column somewhere. Oh no, it's not clear. You're right, it's not clear that all of those cells are, because we could have a 2-cell sum here, right? We could have a 2-cell sum and then a 3-cell sum to 14, and then my 2-cell sum up here. We can fill in that we know that there's a 6 and an 8 in here somewhere. And we know likewise that there is a 5 and a 9 in here somewhere. Let's see, is there only one way this works for 4, or for this purple region, by the way? I certainly have to use the 7. Okay, so the purple region needs to use the 7. That's probably the next thing to notice. And so that 7 that 7 could be here, couldn't it? That's annoying. That is quite irksome. I do agree the green 2 is ending up in column 3, so that does conveniently rule one of those out of there. Okay, so here we have to use the 8. And then we need a 1 and a 5. So this is going to be 8, 1, 5. And so it could either be those, or we could have some additional sum here, and then an 8, 1, 5 running across here. Can this be a 2-cell 14 sum? That is true. This cell's always yellow. I agree with that. That's commonality. So that would have to be 6, 8, which it can't be. 5, 9, which it can't be. No, it can't be a 2-cell 14 sum because there's only 2 of those, and both of them are erased. So in fact, it's those. And we know that this is not yellow, and these are, did I say 5, 1, 8? Yes, 5, 1, 8. Okay. And the remaining yellow digit is a 3 that's going somewhere. Okay, I should write down this remaining contents of this column, which are 2, 3, 4, 7. Okay, so it had better be the case given that this sum here is 7. So the 7 needs to be on one of the ends. And then the only way to do that is with a 3 and a 4. So we can get the 4 out of there. So that's a 2. And these are a 3, 4 with a 7 on the ends. Do we know that that's not the yellow 3? Why can't the yellow 3 be there? Oh, right, right. That can't be the yellow 3, because if it was, then we'd be saying the sum of this line is 3. Right, right. That cell can be a 3, but it can't be the yellow 3. Uh, right, so the yellow 3 is in one of these two cells. Uh, okay, whatever region it is, these two are in the same region. Uh, purple is going to have to do 6, 7, 1, right? Uh, now we get to do the thing I wanted to do with purple before, Carl points out, because I wanted to say, purple is definitely going to use the 7, and that's going to look right, but I realized that actually purple could have bent like that way or something. But no, purple now is definitely putting a 1, 6, 7 in this row. And so that's going to make that a 9 and a 7, and it's also going to make this not a 6, because we're going to have a 1, 6, 7 floating around. And it could either be there or there, I think, are basically my options, or maybe like there. Oh, and this isn't a 1 because of that. I agree with that. Again, we've got a totally horizontal 1, 6, 7 floating around somewhere. Oh, and now remember red, we need a 5, 9 coming out. And so the red 5, 9 is now in these cells, right? So the this cell is no longer red, is the point. Because then I can't get my 5, 9 in. Hey, Dr. Professor Caveman. Do we know the purple 3 doesn't make it all the way down to row 4, Dr. Professor Caveman? Like we could have like a 3-cell thing and then a like 2-cell jutting down or something. That inner ring meaning this one. I do recall being very delighted when this didn't break. Yeah, so we've got a 5, 9 in red over here somewhere. Yeah, I think it's the sort of thing where I'd be unlikely to discover that these days, because I usually now am pretty firm about only putting clues in the grid if I know exactly what they're going to do. And this is just sort of like a just dumb luck thing. And I tend not to find as many just dumb luck things this early in a puzzle when I'm setting now. But arguably that makes some of my puzzles less magical. Uh, uh, a lot of people looking at math in this row, I think basically asking how many 14 sums there are. So if this is a new non-purple region, then this would have to be a 2-cell sum or a 3-cell sum, except it can't be a 2-cell sum because there's a purple 6 in this row. And it can't be 5, 9 because of that. So it would be a 3-cell sum in a new region. And then we'd have a purple 3-cell sum. And the problem is then that makes those all add to 28, 37. And now these two would need to add to 8, and that doesn't work. So in fact, this is the purple sum. Agree. So it is 167. Okay, and so now this is not red anymore. So this is some other thing. Some as of yet to be named thing. At least, that goes there. This still can't be a 2-cell sum to 14, though, because of my previous note that we've used the 6 and the 9. So, in fact, that thing goes over at least here, which locks red out of those. That means this is always red, regardless, so it's not the 6 or the 8. This is the 5 or the 9. Oops. Oh, right, and it can't be 3 cells either, because we already did that math, right? This being 3 cells also doesn't work, because if this is 3 cells, then these two would need to add to 8, and they can't. So it extends even one further, but not further than that, which makes this cell also red. Makes this a 5, 9. That is apparently a 9, and that's a 5. Like that. This is some new region. Previously unknown to us. It can be orange. We don't have an orange region yet. Oh, red still needs a 4. Right, sorry. Right. This is still previously unknown to us. I just was going to not give red a 4 and then be very confused. Okay, now the 6, 8 of green are here. Green probably needs something as well. Green needs a 2, which that cell isn't. This cell just is a 3 now, which makes that a 7 and a 3. This is not the green 2, because if this was the green 2, then somehow the sum of this line would be 2. That doesn't sound good. So this is the green 2. These 3 are all part of some, as of yet, unnamed region. Let's make it blue, but the other blue. These 2 need to add to 11. They're not 2, 9 or 3, 8. So they're 4, 7 or 5, 6. I don't think I know whether they're 4, 7 or 5, 6. Right. Red needs a 4, and it's placed just by sudoku here. 4, 4. I can erase this now. I can probably figure out what these digits are, at least roughly, right? Because I know what these 2 are. These are 2 and 4. So those sum to 6. And so these 2 need to sum to 8. And so they are going to be 3 and 5 or 1 and 7, but they're not 1 and 7, so they'd better be 3 and 5. Which we can even fill in. So that's an 8, and that's 2. So it gives me a 1 over here and a 5 over here. Okay, well, this is orange no matter what. But this is probably also orange. Yes, this is also orange, because what else would it be? It's not. I'm not fitting a 9-cell region in there, so that's definitely orange as well. Okay, this isn't 5. What are these? So these are from 1, 2, 3, 4, 5, 6, 7, 8, 9. In any event, the minimum sum of this line is 7, so these are definitely in the same region. I don't know what that region is, but they're definitely both in it. The purple, I still have to get... I have to get a 2 in purple as well as a 3 in purple. And so the 2 in purple is directly below the 3 of purple. So owing to that, actually, the 3 of purple actually is in row 4, which means the yellow 3 is here, right? Does that sound good to people? So one of these is a yellow 2. Sorry, a yellow... No, I did that backwards. That's the yellow one. No, this is the yellow one. Sorry. Yellow 3 here, yellow 2 there. Sorry. Purple 3 here, purple 2 here. Therefore, yellow 3 here. And therefore, the purple 3 is not here, and it's not here either, because if I do purple 3, purple 2 here, then I break the world. So in fact, it's purple 3, purple 2 like that. This is some other giant region. We orange our way down this. Orange has one more cell left. It can't possibly go there. Because if that were the last orange cell, then it would need to be the sum of these 4 digits, which is way, way, way too large. And it can't be there because then there would be another cell, so we get this region, the comma, if you will. I have never called it anything else. I don't know what you're talking about. Let's see. So these are 1, 6, 7, 8, 9. Those aren't 9. Those aren't 1 or 7. Okay. The minimum possible sum here now is 1, 6, 7, 8. Which is 22, which you can certainly not do in less than 3, which means that, in fact, we're doing it in 5. So this is all one region. And so the only question is it the same region as that or not? Which is, I think, not possible for a very funny reason. Which is that it breaks this line. If I put these two together, it's 9 cells, but now this line is blue, blue, which doesn't work. So those need to stay apart. This region now assuredly needs to take this. Well, it can't take this cell, because if this region takes this cell, now I can't finish blue, and I can't make this blue. So I can put a border there. It's probably just going to be blue. It's probably what's going to happen. Right. One of these 2 cells is blue. No, I don't think I quite know it yet. Unless I'm counting regions. Now, I could pencil mark these cells. Let's see. They can't be 2. They can't be 3. They can't be 4 or 5. I am prepared to say. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Uh, so right. So there's 8 regions not counting these two. So, and those two are different. So one of these two is blue. And the claim is it's not this one that's blue. Because if that one was blue, then it would be 80 million cells. And so this one must be the one that's blue. And so therefore we get that. Okay. That is sensible. True, this cell's never 6 or 7 because we need these to add to 11. Uh, 'Yeah, let's give this region its color. It is the limey green color. Uh, uh, 2 in dark blue is here. I am being told. I believe that. Uh, there's already a 4 in dark blue, so that's a 5 and a 6. Uh, uh, so this is not a 6 for what it's worth. Yeah, right. Okay, what are the digits that are left in here? We still need a 1. 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so these are 1, 7, 8, 9. So the question is this sum 30 or not? If this sum was 30, I would need this sum to be 30, and that seems fine, actually. So maybe I don't know all of that yet. That seems not to be a 5 anymore, so that seems to make that a 5. Doesn't immediately seem to do anything for me, but what are you going to do? Oh, I know that I've known for a long time that this cell isn't blue. Do I know, therefore, that this cell is green? Or do I not know that? Could it be pink is my question, basically. I don't think I know. Oh, pink already has a 4, right? So yeah, so this just is green, right? So it's not blue because blue already has a 3, and it's not pink because pink already has a 4. So therefore, this just is the limey green. Let's see. So we've got sort of so we're looking at math if these cells have the same sum as these cells. Because of the way these things work. So the because of these, yeah. So these are, that's 14. So this is minimum 15. don't quite see how to use that yet. I see a Zackwing on 8s. I'll use the Zackwing on 8s. So that's an 8. Uh, uh, that's what I was doing. I was saying these had the same sum. I just didn't know what the sum was. Let's see. Oh, people are saying these are both 14, right? So I can cancel out basically the whole thing. I see. Right. These are both 14, and these are both equal, and therefore this is just the remaining cell for both, is what people are saying. So these aren't 9. There's no earthly way this can be anything but pink, right? Green now has to go at least as far as over here. So green, after doing something like this, and I'm not claiming it's exactly this, only has 2 cells. That can't get there. Blue only has 3 cells. That can't get there. So yeah, this is just pink. And so therefore it's not 7 or 8, it's 1. And so that's a 1. Okay, so that's a quadruple of 6, 7, 8, 9. So that's the 4. That's a triple of 7, 8, 9. So that's the 6. That's not a 1, and that's not a 1. So that's an 8 and a 3 and a 1 and a 7, which gets me the border there. To tell me this is a non-green thing, which here certainly means it's blue. And this is green, because 3 plus 4 equals 7. I feel like that's going to be green now, but what are you going to do? This is a 6, 8, or 9. Oh, this isn't a 7 anymore. Yes, we can decondiment the 1s. That's a good idea. Okay, what are these digits? 4, 7, and 9. Okay, the only light blue digits left are 2 and 4. This cell can't be a 4, and it certainly can't be a 2, is Emma's point. So it's just not light blue. Which means that this cell is light blue, and in fact, that cell is also light blue, which finishes light blue, making that a 4. Which now is going to make these both pink. 2, 3, 4, 5, 6, 7, 8. Okay, so there's going to be one more pink cell, which is going to be one of these two, and everything else is green. Oh, right. We've already got a pink 9. Oh, I've screwed something up. I still believe that blue can't take that cell. And so now blue takes that cell and that cell. That's a 4, because that's the only digit left in blue. Pink takes both of these. Pink can't take those. I think all of that was right, wasn't it? People in chat were saying something was wrong, but I don't know that anything was wrong. But anyway, this is definitely not a 7. Okay, so then the question is just what is everything else? This cell is pink, so it's not 7 or 8. It is 3 or 6. However, pink certainly is not getting by with only being 6, because these two cells already sum to a minimum of 8. So in fact, this is the cell that's pink. That's the cell that's green. And now we are tasked with making that all work out. This is not a 3 because green already has a 3. Oh, in fact, this is the only spot in green that can be a 5 is being claimed. I would believe that. One of these two is definitely a 2. I guess that's not super exciting. Oh, right. This cell sees the 7 and the 8 from pink down there. Oh, and the 9, actually. So this is just a 6 and a 3, actually. So that's a 4 and a 3. It's a 9 and a 4. 8 and 6. 7. 8, 9 looking across make that a 7. Making that a 2, because that's how numbers work. Making that an 8, a 7, and a 2. That 6, 8 pair there makes these not 6 or 8. That's not a 7 already, so that's a 1 and a 9. Let's see. That has become an 8, 9, 8. 6, 8, 7, 6, 8, 9, 6, 8, and 9. And there we go. We have successfully solved this puzzle. Let me go ahead and put a border around the outside just for completeness. There we go. Okay, the arithmetic at the beginning was way rougher than I would prefer today, but the rest of it worked out well. And I don't think you're going to make a break into a puzzle that is a chaos construction region sum lines without some amount of factoring some triple-digit number. Yeah, I mean, I think the puzzle can be cursed and fun at the same time, as is the case here. But alrighty, I do have time, though, to come back and do another puzzle, so I'll come back and I'll do a puzzle not by me in just a moment. So see everyone shortly. Alrighty, welcome back. For a long time, I said that my favorite setter was 2 to 10th. However, 2 to 10th has not really been setting much lately, so I must admit Nicholas Duhale has stolen my heart as probably my favorite setter at the moment. So we've got a Kropke puzzle here, and I'm going to start by marking in things about where 5, 7s, and 9s can go, because these have to be 5, 7, 9, because you can't put those on a black dot. And so we're going to mark stuff that is and is not 5, 7, 9 and hope it's useful. Spoiler, 5, 7, 9 don't go on white dots next to each other. So we can at least do that much. They don't go on black dots either. So let me go ahead and fill in this 5, 7, 9. So I guess that just means these are 4, 6, 8. Oh, column 3. The rest of the entire column is gray. Good point. That somewhat makes my point about the white dot separating them a little bit sad, but what can you do? Let's see. And one of these has to be a 6, right? Because if neither of these is a 6, then these are a 4, 8 pair, and that doesn't work well. So there is a 6 in one of them, which means there is a 3 in one of these. And regardless of which way around it goes, this is the dot that's a 1, 2, because one of them has to be a 1, 2. I may have done that in a way that was more convoluted than was necessary, but I'll stand by it. So that means that this digit here, which keep in mind that this is by virtue of being a sequence of black dots, this is from 1, 2, 4, 8. But this one's not a 1 or a 2 or an 8, because you can't put an 8 in the middle. So in fact, we get our first digit here that's a 4. We can bring out Zach for the 4 dance. Thank you, Zach. Thank you. So that makes these 2, 8 for what it is worth. So that corner marks an 8 down here, because I need an 8 in this column somewhere, and all of these spots are kind of interesting to have an 8. That would make me a 7, 8, 9, which would look at that, and that would be kind of interesting, but I don't know yet. That's a 4, 6, or 8. Oops. Oh, hey, I probably should have read the rules to this puzzle. That would have been a smart thing for me to do. Because the the puzzle has a rule that is not just Kropke, because so far literally everything we've done is just Kropke, but there's actually more. In the finished grid, each 2x2 square has to contain at least one even and one odd, which is going to mean that there's going to be a 6 in here somewhere, because this square needs a 6 and this square needs a 6. Which means that this white dot actually does have the 8 on it, because this white dot needs an even. And so this is from 7, 8, 9. Which I thought was interesting with this 5, 7, 9, but I'm not sure that I'm really confident that it actually is, having now done this. Yeah, certainly we could contemplate switching to even odd coloring. I'm okay with that. Okay, so is there blue? Is there blue? It might be all the coloring that I know about. Oh, sorry, no, it's not. I know all of those are orange. Haha. See, I did know something else. There's definitely an even in one of these and an even in one of those, but it could be the same even. There's an even there. So yeah, in this box, we can count for all the evens, because there's an even in one of these, there's an even on each of these, and there's definitely an even on the black dot, so this is definitely odd, but also this black dot can't have 2 evens in it because there aren't enough evens in the box. So this is either 1, 2, or 3, 6. Oh, this is definitely even. We just already have it marked as being even. Agree about that. Oh, right. There's just no, we just know this is odd because the 2, the 4, the 6, and the 8 in the column, we know where they are. Thank you. So these are both even. And the odd that this is can't be 1 or 9 or 7, because 7 would break this. So it is just 3 or 5, right? And it can't be 3 because of the black dot, because of the rule that you can't put, if you rule out 2, 3, and 4, you can't make a black dot anymore. So in fact, it's a 5, which makes these be 4, 6, which makes this be 1, 2. So now we in fact have a 7, 8, 9 triple, and so these are in fact just 5, or sorry, just 6 and what? 3 and 6, right? These are 3, 6. So funnily enough, that tells me that this isn't 3, 6. I love Nicholas Duhill puzzles. So that's a 1, 2. Let's see. So there's a 2 over here somewhere. There's an 8 on this dot, just because it needs an even, and the only even available is 8. So this is odd because there's no other even available. This is even because that's how white dots work. These are 3, 7, and 9 is what they're from. This one's not a 3, at least. Oh, actually, this one's just the 3, right? Because the only place for 3 in the row is here. So this is a 2 or a 4. Unless I cheated somehow. Okay, the 1 in this box is not on one of these dots because it would look up at that black dot. So the 1 is in one of these 2 cells. Beautiful. And it goes with the 2 because now the 2 has no friends. So these are in fact a 1-2 pair because 2 would have to go with a 1 or a 3 and it can't. And so therefore these are an 8-9 because we've got to do a 4 with a 5, a 6 with a 7, and an 8 with a 9. So that's an 8 with a 9, and that's a 7, which makes that not a 4, apparently. And so these are a 4, 5, and a 6, 7 in some order. Oh, this 1, 2 looks up and makes that a 4, by the way. That makes these a 4, 6 pair. Makes this not a 9. And that not a 9, which makes that definitely a 9, actually. Makes this a 7, 8. Okay, by Sudoku, there is a 3 on one of these dots. And that 3 had better be in this row, because if the 3 were up here, it would put a 3 in line with a 4. So there's a 3 in one of these 2 cells, which puts a 4 in one of those 2 cells. Just by the way these things work. I don't think I immediately see a problem with this being 4, 3, 2, though. It's weird how this puzzle is like 98% just Kropke, and then occasionally the global parity constraint. Okay, so this... this cannot have 2 as the even number on it, because if it did, it would need to be from 1, 2, 3, and this cell's not 1, 2, 3. So in fact, it has 8 as its even number on it, because 4 and 6 are gone. So this is from 7, 8, 9. Yeah, the 6, 7 here doesn't quite break, although it's close. I know one of these 2 cells is the other 1, 2 for this column, for what it's worth. Oh, this white dot now, it now does have a 2 on it because it doesn't have a 4, 6, or 8. So this is from 1, 2, 3. And that's all the evens for the row. So these are both odd. This is a 5, 7, 9 just by the thing. Oh, right. This 1, 2 looks at this 1, 2, 3. So that's better be a 2, 3, making that a 1 and a 2. And a blue. Very good. These are from 5, 7, 9. Yeah, one of these is even, so it's a 2 or an 8. That's actually useful. Oh, well, I could do even better. One of these is even, so it's a 2 or an 8, but it's a 2. How about that? That's even better. Because I need an even in here, and it's not a 4, 6, or 7. Or sorry, 4, 6, or 8. So there's a 2 in there, which looks up here. Makes that an 8 and that a 2. Which makes this a 3 and that an 8, which makes this 6 and that a 4. Odd. This had better be odd for this 2 by 2, so this is even, and therefore an 8. This is odd, so that's even. Okay. The 579 are a hidden triple in box 4, Zombie Hunter points out. There, and there. Because I need to put them somewhere and they can only go there. So these are from 579, which makes this a 2. Because otherwise that right there is a behated rectangle. And that let's just fill in that 1 and that 2. This black dotted better have an even number on it, or we're completely toast. One of these black dots is 3, 6. These are 5 and 9. I suppose I could have known that if I had remembered the part that I wrote down at the beginning and then erased. These are both odd just by counting. This is even. Agree. One of these is even, but I don't know if it's a 6 or an 8. One of these is even, but I have no idea what it is yet. Oh, these are both odd. I was excited by that, but I don't think it did anything. Let's see, there's a 2 and a 6 in here somewhere. Oh, Soup Nail says this is a naked single. Let's see. I think it could be 1, but it's not 2, 3, 4, 5, 6, 7, 8, or 9. Yeah, it is just a 1. Well, nicely spotted. So these are all even now. 2, 4, 8. This one's not a 2. Row 4, column 2 can be colored. How? I think I'm missing something there. To Todd. These are either 4, 8 or 3, 6. I don't know which way around yet. One of these two is 1. I don't think I know which one yet, but I'm going to mark it. Oh, yeah, it does see all of them. Yeah, very nice. Yeah, this sees 1, 3, 5, 7, and 9. Very nice. I guess basically you're just saying where does 1 go in the box by Sudoku. Is a way to say that sounds less fun. Okay, so now this is forced to be 3, 6 because it can't be 4, 8 anymore. So this is the 4, 8. And this is the 3, 6. So one of these is the 6 down here. So therefore, the 6, remember, goes with the 7. So the 7's up here now. And that actually sorts out this 7, 8. So that's the 8 and the 7. Using the 4 and the 8 over there. That nukes the 4 out of these, which nukes the 5 out of these. So we actually now know that those are both even and those are both odd. Okay, so now that's the one that's even, and that's the one that's odd over here. So there's a 2 and a 1. That 5, 7 looks over there. That is a 9 just by the row. These are a 1 and a 3 in some order that is in fact quite disclosed. So that places the 1 up here. Okay. One of these is a 1, but I don't know which one yet. Oh, yes. 4 doesn't white dot 7 as much. So that's probably helpful. So these are 5 and 9 in some order. And this is the other thing. This is a 7. The only odd left in this row is 3, so this digit's definitely even. So it is a 6, in fact, if I look at it. So these are a 2 and a 3 in some order. However, if this is a 3, then that's a nothing, so this had better be the 2. That had better be the 3. Which we can carry on up there. That is odd and even. Oops. Okay. So that is my 6 and my 4. My 5 and my 7. That makes that the 5 for the box and that the 1 for the box. That the 5 for this box. That is now odd because we see every even from here. So that's also odd and that's even. Okay, that's a 2 just by sudoku. This is an 8 by sudoku. So we got the 4, 8, 4. This is now odd by the fact that it sees every even. So that's even by the coloring restriction. That's odd by the coloring restriction. These are a 7 and a 9 in some order. So that is known now to be the other thing, a 5. Is there somewhere I'm at risk of making a 2 by 2? This is a 5, 7, 9. It's only a 7, 9, actually. Oh, this is known to be an 8. How about that? That's probably useful. So now this is from 5, 6, 7 only. Oh, and apparently there's no 5s on it. So the 5 has been placed here for some time. And therefore that's a 9, and that's a 7, and that's a 9, and that's a 7 and a 9. 7 and 9. Okay, and so now that's going to sort out the rest of our coloring because of this being a 6. So that's going to be even. That's going to be odd. That's going to be even, and that's going to be odd. A lovely puzzle there to Nicholas. As always, I cannot say enough how much I've been enjoying doing all of the recent Nicholas puzzles on stream. They have been something I do pretty much as soon as I spot one hanging out in the bucket. Okay, I bet we can do one more puzzle before stream today. Oh, we've got a Playmaker puzzle. Okay, so the Playmaker puzzle here. Normal Sudoku rules. Along a green line, adjacent cells contain a difference of at least 5. Within a cage, digits don't repeat and they sum to a small number written at the top left. X is an unknown value that is required to be deduced. So these two cells have this, or these two cages have the same sum, is all that we're saying. Okay. Okay, so oh, there's already some interesting geometry floating around over here. This cage is here for aesthetic value only. I need 1, 2, and 3 to make 17. So there's definitely a 1, 2, and 3 in this cage. 6. Let's see. This is a 6-cell cage that's missing 3 digits that sum to 8. So there's no 1 in this cage, is the point, right? There's no 1. And if there's no 1 in this cage... Ooh, James Sinclair streams? I don't think I knew that. So that means that... And there's no 1 in a 19 cage either. So one of these 2 cells is a 1, which seems ostensibly useful. I could fit a 2 in here as long as it goes with an 8 and a 9. Don't know about that. What's the smallest number I can put in here? It's a 4. Oh, I've got a given 8 and a given 9. I didn't see that. It could be interesting. Somehow. So this digit, if it's low, it's or sorry, if it's high, it's not very high. Same about that digit. Black digits are famously invisible. So I guess we're saying something about something very hazily about these. Okay. Maybe I should think about this more dynamically. Because I think if I actually think about the sum here, I think this might be more useful. So 37 plus 19 is what? 56? So if I absolutely minimized this, I would be at 59 there. That's 14 more than 45, right? So that means that these numbers are certainly at least 5, right? If I did this correctly. That's not 8, that one's not 9. Can someone double check my math there that sounds right? This cage has no total. This cage is here to troll Selena. However, it does mean these 2 can't be the same digit. So there's a... So, can there possibly be a 2 in here, I guess is the question. Yeah, I don't see any reason these can't be 8, 9. Based on what I've seen so far, at least. I do know these are at most 7. That doesn't seem directly relevant yet. I can mark these as being high or 5. Let's see. These are at least 3. Am I supposed to be asking something like, where do 1 and 2 go in this row and this column? No, because this cage doesn't have a total. But fitting 1, 2s in this row is tricky because I can shut one of them off here. Oh, right. This one's never 5. Right. Good point, because remember we said these 2 need to sum to a minimum of 14. Well, that one can't be 9, so that just means this one can't be 5. So it does not get the privilege of being green. Okay, if we reverse the math, do uh so yeah, if these aren't both low, then the minimum sum here would be 7 plus 19 is 26 plus 37 63, and 63 is 18 more. Yeah, so these would need to add to 18. So this given 9 here is to make sure these aren't double 9 summing to 18. So yeah, I agree. These are both low. Which makes those both low, which makes these both high. Yeah, I was just being silly about it not being double 9 because of that. Okay, so these are from 1, 2, 3, 4. Okay, does that... Oh yeah, this one's not 4. I agree. Do anything interesting with the sum to 8 that I have to sort of float around here. I'm not quite sure. What is Selena talking about a 17 cage? I don't see a 17 cage. Oh, this 17 cage, maybe. We know it's got a 1, a 2, and a 3 in it. Oh, I see. So Selena is eating one of our degrees of freedom, although I think we still have a lot of degrees of freedom. But these can't possibly be 8, 9, because if these are 8, 9, then we force both 8 and 9 in here, and we know that there's no 8, 9 in these cells. These cells are at most 7. So, in fact, these sum to a maximum of 16, which means these sum to a minimum of 21. So these sum to a minimum together of 40, which means these two sum to a maximum of 5, which means that with Selena's degree of freedom, we got that this digit was a 1, 2, 3, or 4, which unfortunately is what we already had. Basically, Selena's degree of freedom ate up the fact that you can't put a 5 on a German whisper, I believe is what happened. I need to go get myself a glass of tea in a second if Tristan doesn't hear this, but there's a small chance Tristan will hear it and I won't have to. Oh, okay. So that's actually useful because we know it's actually useful in a different way. This 37 cage definitely has an 8 and a 9 in it, and one of them goes in here, and therefore this cage doesn't have a 2 in it. So this cage isn't that. That was maybe not as useful as I thought it was going to be, because I thought it was going to tell me that these had to be a 1-2 pair, but I don't think it quite tells me that. Uh, Garion asks if we can do this with neither of these being an 8 or a 9, in which case they'd be maximum 6, 7. If these sum to 13 or less, then these sum to 24 or more. Plus 19 would mean that these would sum to 43 or more, if I did that right. 24 plus 19. Yeah, I can't make these sum to 43 or more. So yeah, I do need an 8 or a 9, and so that 8 or a 9, whichever one it is, does get pushed here. This digit here has to be an 8 or a 9 by Garion's point. Because whichever of these is 8 or 9 shows up, it gets ruled out of all 5 of these cells and gets pushed there. And now the givens and the cage eat all the 8 9s. Don't we still have... Isn't that only 3 8 9s? Because we've got 1, 2, 3. Where's the fourth one? Uh, oh, you're counting. There's one, right? There's one in here in box 5 somewhere, right? There we go. Okay, that's very nice. So yeah, so right. So one of these is an 8 or a 9. We know this cell's not an 8 9, but one of these is an 8 or a 9, and that's the fourth one because we've got 1, 2, 3, 4, and so that's all the 8 9s. So these aren't 8 9; they're only from 6 7, which is very nice. Which makes these be a 1 2 pair. And makes these be from 1 2. So very nicely spotted to Garion. So one of these really is a 7 at the very least. Which I want to say it does some interaction with this, but I'm not quite sure. Now they could both be 7s. I don't know that they're not both 7s. I just know at least one of them's a 7. If they are both 7s, though, then this cage has a 7 in it. Oh, we can get the exact sum of the outies. That's a good point, because these are 19, 22. Means these sum to 23, which means these two need to sum to 14. So they certainly don't have a 7 in them. And so they either need to be 6 8 with the 6 over there, or 9 5. So this is always a 5 or an 8. I think, if I did that math correctly. Of course, if this is a 6, then that's a 7. Yeah, at least one of these is a 7. The 7 going in here would be very interesting. I'm trying to see a reason why it breaks because of some other thing. I don't quite see it yet. trying to say something like, oh, if this isn't a 5, then I end up with too many high digits in here, but I can't quite make it work as my brain currently sees it, but it probably is something like that. Oh, so we now know which cage this is, by the way, because it's the 1 and the 2 that are missing. So this cage is not that one. This one's missing a 1, 2, and 5. So the 5 in this box is over here because of the 8 sum in the outies of the 37 cage. So this has a 5, which uniquely describes it as being 5, 6, 8, apparently. And so this cage needs an 8, which means that has to be the 8, is the short version of this, right? So that's the 8 and that's the 6. And we can bring out Zach for the 8 dance, if I did that right. Boop, boop, ba-doop. Woo! Boop, boop, ba-doop. Wah! Boop, boop, ba-doop. Wee! Ba-doop, boo-doop, ba-doop, boo-doop, 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 wah! Thank you, Zach. Thank you. The usual crazy playmaker magic of things like very, very slowly chipping away. Okay, so if that's also a 7, things are kind of interesting. These are some digits. Maybe I should just type out what they are. They're not 1, 2, so we've got a 3, a 4, not a 5, not a 6. We've got a 7 and a 9. Those aren't the 7, so the 7 is vertical here. This 10 cage now is a 1, 2, 8, 9 sort of 10 cage. So that's sort of a virtual 8, 9 pair in this column, which is very helpful for this cage. Let's see. This is either 3, 9 or 5, 7. I'm trying to decide if this being 3, 4 breaks. I don't. It does. If this is 3, 4, it breaks. Because if this is 3, 4, then we have 6 cells from 3, 4, 5, 7, 9. And that's too many cells. So this can't be 3, 4. It's got the other 1, 2 in it. Which tells me the coloring of these 1, 2s. Because whatever 1, 2 this is, that 1, 2 isn't that one, which means this 1, 2 is that one. And so this 1, 2 is the other one. And so that is enough to tell me that this is a 7 and not a 6. So that places the 7 there. I feel like I didn't articulate this in the nicest possible way, but I was able to answer the question when I asked the question, is it possible that this is a 3, 4? I was able to answer it, but I feel like I did not answer it in the way probably that Playmaker envisioned that I might answer it. Okay, this 1, 2. This 1, 2 I can play against this 17 cage, because, yeah, this 1, 2 is over here, so this is the other one. Yeah, we can play these 1, 2s. Can't be the same because of the 17 cage. And in fact, this isn't the 1, 2 because of the same idea. The XE 1, 2 is in one of these 2 cells, so that's not a 1, 2. And the OE 1, 2 is in one of these cells, so that's not a 1, 2. So we can do a little bit of coloring around there. This is the OE 1, 2, XE 1, 2 business. And now we can do the thing with the 7s, 8s in this box, right? The 8, we now know the 8 is here, and so now the 7 is here, and so that makes this for sure a 1, 2, 3, 4, 7 cage, which makes both of these low per Garian. So these are from 1, 2, 3, 4. This one we know is not 1 or 2. So this is 3, 4, or 7. I know this is not 1 or 2. One of these is 8. And one of these is 8. Okay, well, now I know there's a 6 over here, because there's no 6 in this cage. So one of these is a 6. One of these is a 9. Right, right. If this were low, it would be 1 or 2, but we know it's not 1, 2 because it sees the X in the circle through the 17 cage. So, because if this were low, it would be 3 or 4, but then this would need to be 8 or 9, and it's not. So, in fact, we go high, high with a low in the middle. Can we make the same argument over here? Sadly, I don't think we can make the same argument because I don't know that that's not a 9. I don't think. Maybe this could be 4, 9 in that case. Couldn't be 3, 9 because of that cage, but maybe 4, 9 would be okay. Okay, this is a 1, 2, or 3. It can't be a 4 because it doesn't go next to a 9. This seems to be the other 5, 6, by the way. I'm trying to decide if I can do anything with this geometry about these two cells. I know that there's no more 1, 2s in these columns outside of the ones in the 17 cage, but that doesn't really help me, I don't think. I know this digit's definitely not a 3. So I guess what I know is that if this is low, it's a 4 exactly, and otherwise it's high. It's not an 8. Can I do some weird voodoo to rule 6 out of this cell? Would make that a 1. That looks fine to me, I think. Yeah, that's very smart. Yeah, this is a 6, 7, 8, Garian points out, which means this 21 cage needs a 9 in it. Just based on the way that you can make this 21, because we can't do that one anymore. So this, at least if it's low, is not a 4. Does it, Ambrose? Oh, yes, yes, yes. It does, yes, because now we ask where 9 goes in this column, and the 9 goes in one of those two cells because of the Zackwing on 9s between these. So this isn't a 9, and that's not a 9, which means this isn't a 4. Very nice. Okay, so we've got all of that. So this is a 1 or a 2, and it's the XE kind of 1, 2. Because it's not the OE kind of 1, 2. This isn't 1 or 2 at all. This is also a 6 or a 7, funnily enough, because it's not 8 or 9. So where does the XE12 go in the 17 cage? It goes here. So this is not a 3 or a 4. The OE one still goes in one of these. Yeah, X in box 5 is here now. The X in this box, I think we know, is not in the 21 cage, right? Yeah. The X in this box is over here. So that places the X here in this box, actually. I think Josh agrees with me. Yeah, Josh seems to agree with me. X in the X cage. How serendipitous. So X now can't possibly be larger than 11. For what it's worth. Oh, right, because there's a 9 already in the cage. So this is a 4, 5, 6, not a 7, could be an 8 maybe. Can't be a 9. Oh wow, that's a crazy spot from Selena. O in column 4 can't go there because there's an O in the box. Can't go here because there's an O in the row. Can't go here because it sees the O in the 17 cage. So therefore O is one of these two cells. So therefore this is a 3, which makes both of those 8. I don't know which of them is O, but that is a very clean spot there to Selena. And so therefore this is not the 489 version. This is the 579 version. Oh, right. The 579 there makes that a 6, which does make that a 1. And in fact, therefore, every X is a 1. And every circle is a 2. Can get rid of our jewelry. So that's a 6. This could have just been a German whisper instead of a cage. No 1 there. That's an 8, probably. What did I just do? I meant to remove 5 out of that, but then I did some random other thing instead of that. The thing we'd said about the 2 was that one of these two cells is a 2. I'm going to just go ahead and mark that because that was the thing that we used. So these are 1, 2, 3, 4 in this box. Our mystery X value is odd. True. Uh, uh, yeah, this is a very pretty setup for this idea. Uh, oh yeah, we can't really put an 8 here without overflowing the capacity of my sum. So the 8 is actually placed there. I agree with that. It's sneaky, but an 8 in the cage would make the total at least 10, and we know it's not at least 10. Which places the 8 up here. And now we actually know this is an 8 just by sudoku on 8s. Which now means that this needs to be either 2, 7 or no, sorry, it can't be 2, 7. So it's got to be 3, 6 is the only option. So we can do that. So there is a 9 and a 3. I was wondering if the X was going to be a sort of like interesting part of the solve. It was not an interesting part of the solve, but I don't mind it as a way of sort of cleanly disambiguating something where presumably otherwise the other disambiguation options would be horrible. And yeah, we should probably hit the mark button at this point. Let's see what Sven can do. So it's Mark can do it, but Sven can't. Okay, so we've got to do at least a little bit more stuff before Mark can handle it all. So this cell sees 2, 3, 4, and 7, so it's not 2, 3, or 4. So this is a 5 or a 6. This 3, 4, 9 triple sees down here, so these are not 4 or 9. And yes, I think you did, AFK. I have a 9 corner marked here, so that means presumably these aren't 9. These aren't 3 or 9 because of that cage marked that way. One of those is a 2. 6 in row 9 is there. Let's see. Can update our marks. I don't think our marks updated very much. This is not a 9 because there's a 9 in the row. Do I know which of these is a 6? Oh, there's a green 5. Maybe that's why I'm not doing this, because I haven't been coloring my my 5s properly. Okay, let's see. This is a 2. This is also green. So that means that there's a green 5 up here somewhere, which means that's not 5. Yeah, this is a 5-6 hidden pair is the point. Yeah, both, because one of these is a 5 is what I said. And so in this box, they must go here, which makes this the 6 and this the 5. Which presumably will help at least a little bit. That 2-4 is in blue and looks up and makes that a 3. That is a 7. That's a 5. Makes that a 4. 3, 1, 2. 4, 2. 7 and 1. Let's see. How much can Sven do now? Now Sven can do the rest of it. Very nice stuff there. Let's see. Let me go finish the coloring now that Sven has helped with the puzzle. Let's see. There we go. You can't call it cheating if I still go and do the coloring. That's my theory. But yeah, very nice puzzle there. The mystery cage value sum is 14. That is true. Yeah, is that the solution code? I hope the solution code to this puzzle in LMD is the sum of the unmarked cage. But yeah, very nice puzzle there, as always, from Playmaker. Playmaker is the master of narrow but very interesting and unique solve paths. Yeah, the break-in here was quite nice. And the way it kept sort of like giving you just a little more and just a little more and just a little more was very nice. I'm a big fan of that. All right, though, I am going to wrap up today's stream there. Uh-oh. Row 4 and row 2. Oh, no. I'm going to wrap up today's stream there, having properly colored the 4. And say thank you to everyone for hanging out and helping with all the puzzles. If you would like to support the stream and you don't already, remember you can always do that by clicking the join button down below in YouTube. And huge thank you to all of you who already do. You can see a bunch of green names in chat from people who already support the stream. Plenty of people support other ways. We greatly appreciate those too. And we try and give you all thank yous on the screen. So huge thank you again to everyone who helps us keep going. And last but not least, thank you to the Turbines, Daniel, David, Franco, Nell, Nordy, Plonktime, and ELSF. Thank you so much. And I'll see everyone soon. Bye for now.